If anyone wants to follow along with anything I'm talking about, I have put a link in the chat. And now I'll spend half an hour working out how to share my screen.
Okay.
Oh, wow, that disappeared.
I just stopped my screen.
Share screen. Desktop 1. Share. I think that's just the easiest.
I can see your screen.
Oh, you can see rubbish. Cool. I'll move that across. And then maybe I'll move that across. Can I still see the chat in case people talk? Chat. Yep. I got the chat open on the left. Hello from other people.
Michael Morris.
Michael Morris. Well, I read the Michael. I thought I didn't say hello. But hello, Michael Morris. Right. And then, oh, where's my browser? It's on this window. Boom. Here we go.
Oh.
Can everyone see my screen?
Yes.
Yes. Oh, thumbs up. Yes, some verbal.
Yes.
Cool. So my name is Michael Millewski. If you haven't worked that out so far, Ceramic is my GitHub and Twitter. The bit.ly datapipe 2021 link will take you to this repo. And I'm going to try and talk about data pipelines in Ruby. Now, if anyone knows, oh, yeah. All right, turn your speakers on. Where do I work?
Not fresher.
Not fresher.
Not fresher. Yeah. So a couple of months ago, I switched to a company called Black Box Co. You would have had a presenter in Celia talking about iterators a couple of months back. What do? We do beef analytics. We are doing that to optimize growth of beef. We're trying to reduce carbon emissions. We currently track around 900,000 cows. That is both cows that have been alive and are still alive. And the plan is that next year we reach 1 million active cows, which is cows that are alive, and we are optimizing their growth and reducing their carbon emissions. That is Black Box Co. But today we're going to talk about data pipelines in Ruby. Now, if anyone knows, every time I do a presentation, I use a new piece of presenting software. So half of my last month was wasted trying to work out how this presentation software works. And you're probably going like, it doesn't even look that special. It's probably not. And then the other half of my time is usually spent looking at anything but what the presentation is about. But let's have a look at what's next. Right, so we're going to cover off what is a data pipeline, or at least Michael's interpretation of one. We're going to say, is Ruby fast enough? And that's probably what we're going to stick with the most. And in particular, is Ruby fast enough in reading CSV? I presume most of us know CSV is some kind of usually comma separated file, but often lots of data comes in CSV format. And also we're going to look at, because this is Ruby and most of us probably are using active record, which is the Ruby on Rails default way of talking to a database. How fast is insert and update? And is there anything new in Rails 6 or Rails Alpha 7 regarding active records, insert and updates? The answer is yes, there is. Right. So first, what is a data pipeline? Well, let's imagine we have some data, usually in CSV format. We want to throw it in a database, and then at some point we want to graph it. That's kind of a data pipeline, but maybe more so it's kind of a number of steps that have a particular format where we have some input CSV data. We would tend to clean that. We may want to remove invalid data, maybe make sure that dates and times are correctly set. We may want to remove duplicates. So that's cleaning data. Usually at that point, you're in SQL, depending on how you're doing things. You may actually still be in CSV. At a later point, you would want to add some features, which is, you may want to go through the data and actually create certain features for, some aggregations and other things around your data. And finally, you'd create a model and then publish and visualize it. And these kind of steps are typical of more of a machine learning or a data science data pipeline. So we are taking data, cleaning it, adding features, creating model, which could potentially mean machine learning models, and then finally making it available at the end. So you may be wondering, what is the data pipeline, or what are pipelines? And I will tell you that pipelines are everywhere. Imagine school exams, and you might be thinking, what? I don't want to remember those. Well, in fact, any paper processing. So this may be a good analogy of any pipeline. If you could imagine that you start with a set of paper, like a ream of papers. So in this case, you've got some exams, and then you give it to somebody and that person hands those out to students. So that's like a separate process of those exams. And then those students sit the exams. Finally, at the end of the exam, someone collects all of that paper and they get a big stack of paper and then give it to somebody else, and that other person marks that paper. And then they give all that paper off to maybe other kind of markers who will standardize the scores, etc. So in general, pipelines are good to think about if you are, as a paper process. And then the results are handed out whether you pass or fail. Right, so I'm going to jump into an example here. Now, tell me with thumbs up if the screen is big enough. I get a thumbs up, so it is. So we talked about one pipeline is where you get this piece of paper or pieces of paper and you hand it out through various processes. Another one you might be familiar with is on the command line. So in most Rails projects, you could cache your log development log file. And I'm just going to head that just to see the first few lines of that. It will have some select queries and whatever else. But then I can actually grep for those, right? So I can, I'll probably grep for anything with the words, probably SQL with an open bracket and head. Head will always return me the first 10. So at this point, I've got a couple of SQL queries. And if I type that again, and I say, right, for all of those, I now want to replace, I want to get the number out, like the milliseconds used to create the PG crypto extension, which I seem to be very excited about. So at this point, I could awk the print $2, the second thing there. So that gives us the times. And then we could pipe that through to another command, which would be, let's say, sed. We will substitute any bracket with null globally. And now we've just got some times with milliseconds. And then, I could type that through to sort numerically, and I get numerically sorted milliseconds. So what we've seen here is Unix tools and pipelines in Unix tools. So you can connect these things together, and what this means is each step feeds into the next step. Each step has a single responsibility. So obviously there, the grep SQL just does one thing, just finds a SQL. The sed, which is a stream editor, just substitutes some things, etc., etc. But you might be saying, well, that's Unix tools. What about Ruby? Well, you can do the same thing in Ruby. So if I Rails console in here, I can do exactly the same thing. I can do a file.open on my log development.log, and I can go through and each line. But if I do each line, it's going to try and read the whole development log, and it could be quite big. So I'm going to do lazy, which will lazily read each line. And then on each line, I'm going to map that line and try and extract it. So in here, I will find anything that has a SQL, and in there, I will grab my brackets. I will grab any numeric that is in there. Numeric or dot that's in there. I will then grab any one of those. I will close with the exit closing bracket and close the regex and grab the first matching thing out of that. And then I'm going to remove the blanks. So I'm going to compact blank, and then I'm going to check if I'm actually on the right track. So we will get the first 10, which is kind of equivalent to that head. That didn't work, which is awesome. Presumably something's wrong in here.
You've got a space before the square bracket.
Oh, classic. There you go. It's good to have some participation. That's still blank. We'll give it one more go. So I have a star. I'm finding the numbers closing there. Oh, I need a millisecond in there because that is the way it does that. So now I've got those numbers. And if I run that again, and now I want to change all those numbers were in strings. So I want to change them to floats. And then I should be able to A that just to see that we've got floats. And then finally I can do a sum. And that will calculate something on behalf of all of that. So we had it in Unix and now we have it in Ruby. We can chain things together. We can kind of pipeline these various operations together. One more example. In here, we're going to find out where we have Ruby meetups in Australia. So we're going to do HTTPS ruby.org.au. That gets us the website. And we're going to use a different chaining then, which kind of came in Ruby 2.7 or something like that. And then says, give me the whole thing that you just had before and return it. So I've got a string. I'm going to convert that string to a URL and open it. I am then going to grab Nokogiri, Nokogiri HTML.parse of whatever's returned from that page. I'm then going to take whatever I have, which should be the whole Nokogiri document, and do a CSS matcher on the ID of meetup locations, which I know is a list and has an anchor tag. And then I will finally, on that, grab the map that through to get the text. And map that to get no spaces around it or no new lines, and run that. And sure enough, there we go. We have this coming through and finding out there are meetups in these cities in Australia. So back to the presentation, we now see that there is a Ruby then, which I think used to be called yield self, or maybe still is. And it again is a pipeline where you can create things and tie them together. And you might be thinking, well, that's all nice, Michael, but what are these things good for? Well, they are composable. So you can easily merge and compose a different pipeline with these different functions. So they're very, it forces you to create very small functions that do certain things. It separates the concerns of each one of those things. So rather than saying like, here is a Ruby meetup finder, I can actually create various functions that do separate things. Like one says, I'm going to change this into a Nokogiri document. Another one says, I'm going to fetch that URL. Another one says, I'm going to strip text out. So they're very separate concerns. And that also means that these things become horizontally scalable. So like the exam, so as we were talking initially about a paper exam that gets handed out to lots of students, you are actually then horizontally scaling it. Every single student is filling out their copy of the exam. So same with a lot of this pipeline stuff, you can then scale it by getting other machines to do parts of whatever you are doing. And one important thing to do is, in general, you want to make these things idempotent. So, I mean, this is a completely separate topic, but once you're going down this path of composing these things, you want to make sure that, and especially if you go down the scaling side, you might want to make sure that these things are idempotent and they don't step on each other. So hopefully that's kind of an introduction to what pipelining things is in general, or at least Michael's view of it. So coming back, you could do this with data as well, like we were showing small examples, but you could do this where you get a whole heap of CSV data and you clean it, and then you add features and create models. So your actual pipeline could be processes that take hours to perform by themselves. But as I mentioned, most of the talk is going to be about speed of Ruby or lack of. CSV to database is the first thing you want to do. So most of our data comes from CSV, whether it's just data import that you might be doing in your own thing, or in the case of where I work, Black Box, we get a lot of our data feeds in CSV. And in fact, most data sciencey feeds tend to be in CSV. So most people tend to process CSV files to do their machine learning, etc. So you may want to do this. And in this case, I'm using this example data set, which is yellow trip data. Yellow trip data is the yellow cab trip data, which is available freely, used by a lot of people. It tells you about every trip. In this case, it is all the trips on January of 2020. And this data file is 560 megabytes long. So one way of reading this could be using CSV, read the file, understand there's some headers, and just to make sure I've read it, I'm going to print out the first two lines, the last two lines, and do a data count. And I'm going to run that through a benchmark. And lo and behold, it takes 170 seconds on my M1 Silicon laptop to do 560 megabytes, which that's not too bad. A couple of minutes, I can do that. But then you're thinking, well, how fast could it be? So how fast would it be if I just used plain old Postgres and read the data straight in? So Postgres gives you a command called copy, and copy kind of basically just says copy this data from one spot to another. And one of the spots you can do it from is a CSV file where you pass a delimiter and a CSV header. And in this case, successfully it copied 6.4 million data sets of that 560 megabytes. And it took 22 seconds for the same 560 megabytes. So come on, Ruby, I'm sure you can do better. So at the moment, Ruby's on 170, and just putting it straight into SQL will get you down to 22 seconds. So we know we should be able to do better than 170. So you might be saying, hey, Michael, faster CSV. Well, I tried it. And if you run faster CSV, you'll be told that we are already using faster CSV, because as of Ruby 1.9, Ruby's CSV is faster CSV. So that's not helping us. But looking out, I'm going to have to Command 0, right, resize the form. Right, so looking around, there is a thing called RCSV, which is a little bit more kind of, I presume this under the covers uses C libraries to try and actually parse the CSV. So as you can see, it doesn't do the file opening for us. I still had to open the file separately, but it does the CSV parsing for us. So at this point, I'm saying, well, I can parse the CSV. So at this point, I can read, I can do a count and print a count. And let's see if that's any faster. Well, it's a fair bit faster. It's 28 seconds to read that 560 megabyte file versus 170. So certainly if you are starting to process some large data sets, turning to something like RCSV, if you need to do CSV parsing, might be better. But this is, let's recap where we're at. So at the moment, we're saying SQL copy, just reading a CSV straight to the database is still the fastest, but we can use RCSV and we can use CSV. But certainly there's quite a big difference between CSV and RCSV. So certainly that gem is worth a look. But surely, can we go faster? Python. This is not a talk about Python, but Python is the language that most companies or most people do a lot of machine learning. And one of their core libraries is Pandas, which allows you to, amongst other things, read CSV. And you read it into a data frame. And trust me, once you've read it into a data frame, Python actually spits out the first 10 and last 10 lines. So it's actually read it and processed that. So any guesses? I'm going to go to the audience participation. Any guesses of how fast Python Pandas is? 8 seconds from David Carlin. It's too slow, too slow. 6.87 seconds on a 560 megabyte file. that kind of surprised me. It's a lot faster than actually just reading it straight into Postgres, and way faster than Ruby. Can we go faster? Even faster? Yes, let's do it. So I had a look. I believe this is the fastest I could get, Apache Arrow. So this is a relatively new-ish project. They have an idea of trying to store data on disk the same way it would be stored in memory, which means you can really quickly read an Arrow file and process it. The idea is if we can standardize on the tools for reading and writing files through something like Apache Arrow, then we can start to build better software on top of it. 1.45 seconds for the 560 megabytes. The main advantage Apache Arrow has over Pandas is it's multi-threaded. So if I'm running an 8-core machine, we are down to 1.45 seconds. Surely we can do something better with Ruby. Well, we can. There is Red Arrow. So if you actually go to Apache Arrow, they say we support Ruby. And when I was doing this talk about 2 weeks ago, I had a look and I was like, oh, this is going to work, because the gem was not updated for 4 years. But basically the gem just reaches out to a C file. So maybe it will work. I checked this yesterday. They actually had an update a couple of weeks ago after I checked it. Some new format or something is available. Let's run that. 2.28 seconds. So at this point, we've actually read an Arrow table to load, oh dear, an Arrow file. So the only thing here is we're actually loading an Arrow file. So all the way up to this point, we were loading a CSV file, but Red Arrow allows Ruby to read an Arrow file. So I actually created the Arrow file using Python. So I used Python to read the CSV quickly, push it into an Arrow file, but all the same data is in this Arrow file. And at this point in time, I can pretty print the table, which gives me like an overview. I can go through the records if I want to, etc. I'm in Ruby world, and I've read the file in 2.28 seconds for 560 megabytes. To summarize, we have the benchmark I'm kind of setting as PyArrow, which is Python using Arrow. And then along the side, we have how fast the relative speeds are. Obviously, Ruby's RCSV kind of struggles, but it's much better than just plain old Ruby's CSV. And certainly, if you're doing a lot of this kind of stuff, and if you were trying to manipulate the data, probably sticking with something like Pandas or maybe going down to PyArrow may be best. So that's the first part of what you might want to do. You might want to read your CSV data in. But what's the next thing? Well, once you've read that data into your file and you're kind of reading it and cleaning it, you may want to insert it into SQL. So what do? Well, we use active record, of course. I think you can ignore that line. That's just kind of using some headers and whatever else. But if we go through each one of these 560 megabytes, these 6.4 million records, one way in active record would be to go and create a yellow trip datum. I learned datum is singular for data. So my data table is made up of datum. And when we do that, we can have a look. And in this case, I'm only doing 100,000 records just to kind of, I only had so much time. So plain old active record, 179 seconds to do 100,000 records, just the way we'd typically imagine doing this one at a time. But obviously that's executing a number of queries, so we can do better. Yes, we can. Right, so if you went off to the internet and tried to find if you could do this faster, you would find articles from the last 2 or 3 years. How to grab faster thingo, fastest way of importing data with Ruby, importing data quickly in Ruby on Rails applications, and importing data to databases 50 times faster than normal. And what do they use? Well, a number of them go down to actually using raw SQL, but mostly they use this gem, active record import. What active record import does, it allows me just to call .import on my model. I pass through the headers and I pass through any number of CSV records. In this case, I passed through 100,000. So we were at 170 seconds using plain old active record. We're now down to 9.73 seconds to process 100,000 with the help of an external gem, active record import. But at the beginning, I said Rails 6 can help us, and it can. Rails 6 came with insert all. And insert all works very similar to import. You have to pass it the headers that you want. You, in this case, create like a hash of key value pairs, and you just do an insert all. So if you're running Rails 6, you can insert all and 7.88 seconds. So it's slightly faster than import. Just to overview that. So we said one by one. Okay, I thought we had a different time here, but anyway, it must have been a different run. But active record one by one is like a factor of 10 slower than either import, or now you don't need the gem. You can just use insert all. But I did say something about Rails 7. Let's see what that is. So we're back where we're at. We're talking about data pipelines. We're saying you want to read CSV. You then want to have clean data by inserting into SQL. And then we're saying, well, once you've inserted it, you may want to add some features. So you may actually want to reprocess some of your SQL. And we saw the benefits of creating a pipeline so that you would have one thing that does an import, another thing that maybe does a clean, and another thing that doesn't add features, because that means you are composing of various functional things. You could split this across different servers, etc. But to add features, you want to read SQL and write SQL. So let's see how Ruby performs there with an update SQL. So you could do the same thing. You could use active record, plain old active record. And in this case, let's imagine one of the fields in the yellow trip data is a trip distance, where it tells you every single taxi trip distance. And in this case, I've applied my satanic algorithm of always changing it to 666. And for 100,000 records, to do one record at a time is 91 seconds. If you're doing the same thing, but changing it to 77 using active record import, you need to do this. But at this point in time, you're not doing an update, you're doing it still an import, right? The same thing we were doing before, which means you have to tell it what keys you're sending to it, and the records are just literally an array of arrays, but you're going to hit duplicates, right? You're going to actually say this ID is already taken because it exists. We're actually updating it. So in active record import, you have this extra option you can pass on duplicate key update. So it says, if I found a duplicate, which I would because I'm using existing IDs that I want to update, I need to update these keys. And running that, we're down to 3.43 seconds. So a lot faster. But you're saying, Michael, we can do upsert all. Well, almost. We can almost do upsert all. So this would be the same idea that we're recalculating our trip distance, and we want to just populate the whole database with this new calculated value. But again, we're going to have to deal with duplicates, because basically we're just passing it every ID and its new value. And unfortunately, upsert all currently in Rails 6 does not deal with duplicates. But when I was searching on the web, I did come across what Edge Rails is doing, and Edge Rails just has a simple flag on duplicate update. This is not available right now. It was tricky. I'd be keen to hear how people use Edge Rails, because active record, I couldn't just pull active record. I had to pull all of Rails and Edge Rails to be able to use this. But when I did, lo and behold, it's slightly faster, and we're probably not tracking all these times. So let's overview it here. So we're saying that to do the update, so if you're doing your processing in Ruby and you wanted to read an update, plain old one by one is about 180 seconds, give or take. Active record import is 3.4, and upsert all is faster. But upsert all will not work if you've got existing data until Rails 7 alpha. So currently, for some of the stuff we're doing, actually we are doing at Blackbox, we are using active record import, trying to get that benefit, and we are using RCSV as well. Data pipelines in Ruby, so your mileage may vary. Certainly, so there's certain scale you may reach with Ruby. Use RCSV for CSV. Insert and upsert all is coming in Rails 6, or well, is in Rails 6, but upsert all won't work if you have existing data fields. So maybe still use active record import. It is worth benchmarking some of these things, because it may be the difference between spending minutes and versus seconds on doing it. But as I said, your mileage may vary, and at some point you're going to probably have to bite the bullet and move somewhere else. that's it. But as always, I've got lots of things going. So I thought I'd quickly share what's up next for me. One of the things I got really carried away whilst doing this was I thought I wanted to get some really cool data, and I wanted to visualize it in a cool way. So I had to look at the census data, because the census is actually coming in August. So I thought, what do we have in there? And we've got some data about how many IT professionals there are. There is data about how many people work from home by geography. I'm sure that's going to change drastically. So I started looking at that, and I came across DecGL. I don't know if anyone's heard about it. We're all talking about Uber. One of the things Uber has spent its billions of dollars on is creating DecGL, which is a mapping layer visualization thing in WebGL that is amazing for doing plots like you can see there on the right-hand side. So I'm planning to continue my project on playing with census data, maybe getting it ready for GovHack. I don't know if anyone's interested. There is a GovHack coming up, 22nd of August. I will hopefully have some census style mapping data, which I'll merge with something at GovHack. And I also do plan to go to the Rails camp September Adelaide. So if you're keen on joining me on any of those things, either reach out on Slack or in any other way. Otherwise, I will keep you posted, and you will no doubt hear from me soon again. Thank you.
Woo! Awesome. That was great. That was really good. Any questions?
So I have a question. Michael, when you were reading the CSV and you just wanted to get the first 2 lines, did you ever consider just using the Unix head command?
Well, did I consider it? Yes.
Sorry, I'm just trolling.
I expected that. No, absolutely. I mean, as I said, it was interesting to see that once you start using some of these real tools like the Python stuff and the Arrow stuff, that you did get magnitudes faster. And certainly, like, certainly Unix tools are always cool, and they're very good, very fast. And again, they're very good if you are kind of keeping your separation of concerns and just saying this one little Unix tool does something. And in fact, I wrote something just today where when we process a data file, we want to kind of tell the user how many lines are in the file, because we kind of clean it up just to see how many lines we've cleaned up. And sure enough, I went straight down to WC, which is word count with a -L. And I used that to just be the fastest way for an import to say, count the number of lines. So in this case, no, but certainly I'm always very open to using Unix tools when it's the right tool. I do worry that ultimately you're trying to do some processing, hopefully, which I didn't really show here, but at that point, you can do it in Ruby, and we currently are, where you're kind of, and in particular, if you're processing stuff and you need state, right? Because if you're just changing, dates to be valid format or anything else, you could use anything. But once you're tracking state to say, this cow went through this kind of process, was feeding on this kind of food on this paddock for so long, and then what happened? Once you're starting to use state, you need a programmatic language, at which stage Unix tools will give you limited results. Brendan, question.
I actually did the same thing of implementing WC-L myself, I think a couple of months ago, but discovered recently that it doesn't actually work all the time. Like it can be inaccurate because it's not actually counting the number of lines, it's counting the number of new line characters. And so if your file doesn't end with a new line character, you can end up with an incorrect result. Yeah. And I was going to ask, did you compare the generated SQL from those last 2 methods, the upsert and the Rails Edge one?
No, that was like a kind of, I should really have a look at what they're doing different, because obviously they are generating SQL, and a number of those articles kind of go quite deep into creating temporary tables, and that's even faster than using those gems and those upsert alls. So if you actually manually create a temporary table and insert it and then copy from that table into the table, it is faster. But I didn't look in depth into that stuff. I thought I'd leave that for the reader. That can be exercised at home. I'd be keen to have a look at why one's faster than the other, but I'm not sure.
Awesome.
Hello.
Any other questions? Sounds like that's it for now. Thanks, Mike.